Hello children, we are doing class 12 chemistry, unit 4 chemical kinetics. Introduction and important formulas, few important formulas related to the sums. So here rate of reaction equal to, whenever during a chemical reaction from reactant to the product, rate of reaction equal to decrease in concentration of the reactant. Reactant decreases, so decrease in concentration of reactant divided by time taken. So minus delta R divided by delta T. Then when the reactant will decrease, product will increase actually. So that means increase in concentration of the product divided by time taken, equal to delta P divided by delta T. Now unit of rate constant is rate. Rate is concentration. Concentration's unit is mole liter raised to minus 1 divided by time taken's unit is second. So when you take it to the numerator, mole liter raised to minus 1, second raised to minus 1. In gaseous state, it will be atmosphere, second raised to minus 1. Then for a general reaction, A plus BB gives CC plus DD, where small letter A is the coefficient of capital A, B, so stoichiometric coefficients will mention. So instantaneous rate of reaction will be equal to minus 1 by A. Why minus? Because reactant will decrease and this stoichiometric coefficients reciprocally have to take. So into D, concentration of A divided by dt equal to minus 1 by B into again dB by dt, that is concentration of B divided by dt, and again the product's concentration will increase, so it will be 1 by C into dC by dt, and other one 1 by D into D into concentration of D by dt. Then that one is the instantaneous rate of reaction. Then by rate law expression, if rate equal to K into A raised to X into B raised to Y, then A is actually the concentration of the reactant A and B is the concentration of the reactant B. So where order of the reaction with respect to A will be X and order of reaction of B with reaction with respect to B will be Y. So K is the rate constant and overall order of the reaction will be N equal to X plus Y. Now for identifying the unit of any rate constant, you can find out by its general formula, mole liter raised to minus 1, 1 minus N, second raised to minus 1. So for zero order reaction, N equal to 0 actually. So when you substitute N equal to 0 in this equation, 1 minus 0 it will become. 1 minus 0 it will be 1. So unit will be mole liter raised to minus 1, second raised to minus 1. Now for first order reaction, K. So first order reaction means N equal to 1. So it will be 1 minus 1 will be 0. Any number raised to 0 is 1. So it will become mole liter raised to minus 1 will become now raised to mole liter raised to minus 1 raised to 0 it will become for first order reaction. So only delta left will be second raised to minus 1. Now for the second order reaction, one time I will show the calculation. So for the second order reaction, it will be K will be, unit of K will be mole liter raised to minus 1, 1 minus N second raised to minus 1. Since N equal to 2, we'll write that one as it will be equal to mole liter raised to minus 1 and N is 2 actually now. So mole liter raised to minus 1, 1 minus 2 second raised to minus 1. So it will be equal to mole liter raised to minus 1 raised to minus 1 and second raised to minus 1. When we will give the power minus 1 for each term, it will become mole raised to minus 1, liter, minus into minus will become plus, liter and second raised to minus 1. That is the unit. And here I will write because N equal to 2. Now next one is integrated rate equation for zero order reaction. When you do the derivation, you can see that rate constant K will be equal to R0 minus R divided by T you will get, where R0 is the initial concentration of the reactant and R is the final concentration of the reactant. And now we will do some more formulas. Continue. Hello children, we are doing now half-life period for zero order reaction. T half equal to concentration, initial concentration of the reactant divided by 2 into K, where K is the rate constant again. So here K equal to rate constant, K, where K equal to rate constant. Now here integrated rate equation for the first order reaction, is rate constant K equal to 2.303 divided by T, log concentration, initial concentration of the reactant divided by final concentration of the reactant. That one can be written in terms of 2.303 divided by T log A divided by A minus X, where R0 and A are same only, initial concentration of the reactant. If X moles of reactant changed into product in time T, at that time the left out concentration, that is the final concentration of the reactant, will be equal to concentration A minus X also. Then again half-life period for first order reaction, T half equal to 0.693 divided by K. 0.693 divided by K. So it is independent of, which is independent of the order of reaction, which is independent of concentration of the reactant, which is independent of concentration of reactant. Now, which is independent of concentration of the reactant. Then, next one is for a gaseous reaction. For a gaseous reaction, A gas gives B plus C. So, at time T equal to 0, Pi is the atmosphere is the initial pressure. At that time, the products are absent. So, 0 and 0 moles. 0 and 0 atmosphere was the pressure. But after time T, a part of the pressure of A will decrease by X. So now new value of the pressure will be Pi minus X. So that the pressure of B will increase. How much is decreasing in A? How much pressure is decreasing in A? So that much pressure will increase in B and C. So the final pressure of the reactant Pa will be 2 Pi minus Pt, where X equal to Pt minus Pi will get by calculation. Then Pt is the P total. Later we are writing rate constant K equal to same thing only 2.303 divided by T log. Instead of initial concentration, it is initial pressure of A, the reactant, divided by final pressure of A. So initial pressure of A by calculation we got. Initial pressure of A was given in the question. Final pressure of A by calculation will get 2 Pi by Pt. Then Pi initial pressure of A, Pi final pressure of A, which is 2 Pi minus Pt, and P total will be equal to total pressure of A, B and C, that is Pa plus Pb plus Pc. Thank you children.